It is really a privilege to be here today. This is my first time in London, and it's a really great opportunity, so thank you very much for having me. It's also really a privilege to follow the first three speakers we had this morning. This content, and maybe somebody here had a crystal ball and they did this, they could see the future, but this content actually really progresses out pretty well. So I'm actually going to build upon some of the things that were covered in all three sessions, and it saves me from having to go into detail on a bunch of stuff, so that works out great. Just to introduce myself, my name is Michael Green. I'm a Principal Program Manager. So the CAT team is part of Enterprise Cloud Engineering, formerly known as Windows Server System Center, and it's our job to drive customer validation, essentially. So everything you've heard about Satya driving more customer feedback into product development, we are one of the teams that focuses across all of the teams at driving that. And the concept of a CAT team is very popular these days. So Azure has a CAT team. Azure CAT also includes SQL CAT. Visual Studio has their version of a CAT team. I actually previously worked for the Office CAT team. And we all have basically the same function, which is go find out how customers are using the stuff that we are about to release or just recently released. So we run what you previously knew as the TAP program. Now it's called Continuous Customer Engagement, where people have early access to builds and help us identify the quality and if we missed any scenarios and things like that. But we also do this thing called technical enablement, which is always kind of a shifting landscape. And it really depends on what the individual is focused on as to what it means. For the last year or so, I've been really focused on meeting with customers and trying to understand if we're getting it, if we got it right with Windows Management Framework version 5, and then kind of what are they doing with automation these days, specifically anything around PowerShell. And we've got a lot of interesting projects going on. This led to me partnering up with a guy named Stephen Murawski, who I'm sure you've heard of. He works for Chef. And we published a white paper. And the general idea was, we kind of felt like there was a gap in content out there where if you have spent the last 10 years building a career and developing knowledge around Microsoft technologies, and now this concept of DevOps is coming through and your organization might be changing, or you as an individual might be trying to identify how you can be the initiator of change within your organization. Nobody had really published something that said, this is what this means to that skill set. And so we tried to take that on. And we released this at PowerShell Summit. And we've had really, really good response so far. It has been downloaded over 4,000 times, which is really high for the white papers that I've managed in the past. So if you'd like to get in touch with me, you're certainly welcome to connect with me here, and we can exchange contact information. But on Twitter, I'm at migreen, and on GitHub, I'm mgreengit. Twitter direct messages are probably as effective as email right now, just because as I travel, trying to dig out of my inbox is never fun. And then the URL to the white paper is just aka.ms/the release pipeline model, or if you want the shorter version, which I created because of Twitter, because not all clients are the same, you can also just use aka.ms/TRPM, and it'll take you right out to the white paper. And I noticed earlier, whenever Jeffrey was asking kind of the profile of the audience, there's a whole bunch of people back here who have been doing DevOps, and then there's kind of an intermix of people who are new to this concept. I think for people who are new, the points that we're going to drill in on are, what does this mean for operations? And so we're going to go through a lot of the CI/CD concepts and explain, what does this even mean if this is new to me around operations? For people who have been doing DevOps, either this is going to be really boring to you, hopefully not, or you'll be able to take content either from the slide deck or from the white paper and use that whenever maybe there are others within your organization who need some convincing. If you have Windows admins that haven't seen the light of day yet, you can use this to kind of bring them around to the good side. So it's interesting. And we do go into details, not necessarily how-to details, but kind of thoughts around what it looks like to bring new tools and old tools together. So I want to start here because especially for people who are new to these concepts, you kind of have to frame how big of a change are we talking. And I really thought this was an interesting way to look at it. And there's a book by Thomas Kuhn, The Structure of Scientific Revolution. A friend gave this to me, and then he spoiled it by telling me what to read, and I didn't read the rest of the book. I just got this point out of it. And that is, for an idea to become a revolution, it basically has to solve the new problems, and it has to solve the old problems too. If it only solves the new problems, then it's just something that's interesting that comes up on our radar, and then eventually it goes away. If it addresses the new problems, and it's a better way of solving the old problems, then it sticks, and then it becomes something that revolutionizes the way we're approaching a space. So to me, the way that I rationalize this into this problem area is to say this concept of the cloud has come along, and we've got a new set of tools and processes that allow us to address the challenges associated with managing clouds. Now, DevOps obviously covers a much bigger space than that, but if I drill down into what does this mean to me day to day, technically, looking at tools and processes, the concepts that start addressing cloud space are the new portion of this. And then how do I know this is going to stick? Because the concepts that I'm seeing here also are better at managing the old problems. And so that's kind of how we're going to relate the subjects. All of the ideas in the white paper are not original to us. We're taking concepts that are well established and just discussing what does that mean for the WinOps atmosphere. So there is no shortage of reading material if you start looking for content. If you're looking to decide what book to read next, Stephen Murawski, under his blog, has got his DevOps reading list, and it is actually where I go whenever I'm looking for my next book to read, and he's usually a book or two ahead of me, and I just go find what's the next thing that he read after me, and we have regular conversations, so that allows me to stay relevant to what he's thinking about. But there's a few on here that were especially influential, but all of these are really great. And this slide deck is on GitHub right now, so I'll share the link to it afterwards. But this is a little bit of what I've been seeing. Across the customer landscape, if I go meet with 5 customers in a week, and it could be 30 customers on the phone, or if I go on the road, I might go to 2 or 3 cities in a week and meet with 5 or 6 different customers. I'll basically see 2 profiles, and I can see these in the same day. I'll go meet with somebody in the morning who is well down the path of using release pipelines and using DevOps type practices. And they're basically like, yeah, thanks Microsoft for showing up. We're well down the path. We've got this pretty well figured out. If you can show us, some tips and tricks to make us more effective managing Windows with this, that'd be great. But our process here is well defined, and we're mostly learning from those opportunities. And then in the same day, I could meet with somebody and say, let me explain to you what I saw this morning. Are you guys doing anything like this? And they'll basically say, that's a little bit more dev from what you're describing than the IT pro experience and the skill set that we know now. And then you have the majority of customers by far who are just saying, I'm trying to just keep all of the hair that's burning on my head, the hair is constantly on fire. I'm trying to duck my head in a bucket of ice water to get that put out. I can't possibly even come up to look at something new right now. I love this illustration for that purpose. So this is the way I've come to think about this. This is kind of the way that I rationalize this idea. This is also the first time that I'm trying this slide in front of real people, so we'll see how this goes. Especially looking at something like Azure and just services from Microsoft, I keep noticing this pattern, which is if it's software as a service, so something like O365, you're consuming that as something that you can just use, right? You can manage the user provisioning and things like that, but you're a consumer of that concept. For platform as a service, for something like I'm just going to provision a database, or I'm going to provision a web hosting service and build my apps on top of that, now you've got this expectation that the fabric underneath there is going to be very, very consistent, right? Every time that you want a database as a service, the underlying infrastructure that supports that database is going to be exactly the same. But then as we go up to infrastructure as a service, you have that same expectation with the underlying fabric, so the storage should always work the same, networking should always work the same, and then you provision, or not you, but we, anybody who's an IT pro, we provision that VM, and then we immediately remote desktop into it and start just randomly configuring it. And that we would never, ever allow that if it was platform as a service. If the people who were providing database as a service were to remote desktop into the underlying infrastructure and just configure it based on their knowledge of how to build database servers and just do each one, number one, they would never scale. And number two, there would eventually be outages because everyone would be just subject to human error. And then we would never stay with that provider. But we do this to ourselves. So we go provision a VM and we don't treat it as platform as a service where we've got the ability to apply a custom baseline and make it meet our business requirements. And if we have additional security regulations, we can apply those to infrastructure as a service and then treat it like platform as a service. But instead, we just do this to ourselves. We talk about server configuration drift, how much of that is caused by our own practices. So normally I explain what is configuration as code. I think Ed's already done a brilliant job of doing that for me. He walked through what does DSC look like and what is configuration as code and how does that actually function. The thing that I would bring to the table as far as configuration as code, and why does that matter so much for Windows Server? So Windows Server has, at least traditionally has, a lot of different APIs. So as scripters, you have seen modifying the registry versus modifying the file system and modifying something that's a WMI setting as opposed to connecting to Active Directory and setting things there. So if you look at what's the power of DSC and the examples that Ed was showing earlier, it's taking all of those complex ideas and the modules behind the scenes are doing the heavy lifting. You're just going to give basically answer file level of information that says this is how this server should always be. I look at ARM, or Azure Resource Manager, as the same type of concept, but now let's open our heads to all of the infrastructure. So especially in the infrastructure as a service space, what does it look like to say, beyond just how that server is going to be configured, what are my networks going to look like? What does it look like if I need to have multiple network adapters in that server? What do my drive configurations look like? What are the storage requirements for this? What if I want to have a very complex environment that includes hosted websites, hosted databases, and some VMs that are providing infrastructure in a multi-tier type architecture? So I also look at that, and then most of my examples today will be PowerShell driving Azure Resource Manager. And then I want to touch on this last point, which is as you start looking at whether it be Chef, Puppet, DSC, Azure Resource Manager, and you start thinking about the world as just declarative syntax. And I think we see this a lot in the package management space where, oh, I can install this app as easily as saying install package name. I don't need to know anything about that app. I'm sure it'll work fine, right? And nothing replaces the years of experience that everybody in this room has built up around managing infrastructure, managing just the core components of what it takes to run IT. And so all of these concepts are great for rationalizing how we're going to deploy and maintain an environment, but none of it replaces the knowledge that you have and what that means for enhancing these environments. So the way that we've kind of deconstructed the concepts that we're going to go through today, we took this whole idea of configuration as code and what it looks like for that to end up in production. And for those of you who are already familiar with CI/CD, or if you saw the session this morning, if you were thinking about release pipelines and you were wondering what are some of these moving parts, this is how we broke it up. So basically source control, running a build service, automated testing, and then releasing into production. So source, if we think about this as what is it really, and then why is it relevant to operations, I like to relate this back to change management. So we've all been through this before. There's an outage, and we're trying to figure out what changed in the environment, and we don't have a good historical record of what changed. So let's talk a little bit about what that was like. So first, if we wanted to introduce change into production, hopefully we spun up a VM. We would go in and actually make the change, usually manually. And manually doesn't necessarily mean that we did it via point-and-click methods, but keep in mind that you can randomize a server using the command line just as effectively as you can using a mouse. So we would go in, prototype our change in a virtual machine. We would then submit a change form, right? So we probably filled out a Word document, put that into SharePoint, because we all love doing that kind of thing. And we'd go present to the change advisory board or change advisory committee. And then at that point, we kind of argue as a group, we have to make this change? Really? How important is it? Do we have to make it right now, or can it wait until there's fewer changes going in at the same time? And we try to rationalize what that all looks like. And we kind of have that conflict and get it resolved. And then obviously we go update our build documentation, because if we ever want to reproduce this server, we need to have all of our current changes included in what we're doing to build that. So the first thing we do is we forget about prototyping it in the VM, because we've got a pretty good idea that if I turn on this group policy, it's going to work exactly like I think it's going to work. And then we don't update the documentation because we hate documentation. So forget doing that. The next thing we do is we don't submit forms, because we've all been within our companies for a long time, and I'm done with these forms. I'm just going to go to CAB and I'll just shove this in their face and they can take it or leave it. And then, of course, because of that, because of our seniority, we no longer actually do any sort of conflict oversight. Everybody just kind of says, yeah, I'm sure Michael knows what he's talking about, so we'll put that in production, that's fine. And then eventually we just go to CAB and argue, which leads to just arguing about what we're going to do. Because the only way to be really effective in this process is if you never actually let a change into production. And the reason that this is so painful is because we don't know what production actually looks like. We don't have any sort of real historical record that says, what does this look like in production? This is a really extreme statement, but I actually think at some point down the road, the idea of connecting to a server and making just manual change will be seen under the same type of light as a security incident. Because you think about it as, okay, yesterday there was an outage. Yeah, there was. So how did we get out of it? Well, I connected in over RDP, and I just beat on this server until it came back into submission, and now the service outage is over and it's back. Well, it says, according to the logs, that you were connected for 90 minutes. Yeah, that's about right. Well, what did you change? I have no idea, right? I stopped and started services. I uninstalled some stuff that didn't look like it should be there. I patched it, and now it's, for some reason it's working again. And now when we go into that next change window on Saturday afternoon, who knows? There could be pending file changes and things like that. So that server could go flat and never come back from that reboot. And that's why change windows are terrifying, because we have no idea what's actually in production. So what do we do now? Everything is configuration as code. So whether it's DSC, it's ARM, you name it, we put everything into source control. That includes if we go get a random script off the internet and we decide that we're going to run that against our production environment, which may not be the best idea. Everything that we're going to do in production starts with source control. We're literally going to manipulate everything from our workstation. So the process would be similar, but we're going to take the latest version of what's in production, clone that to our workstation. If you're familiar with tools like Vagrant, you can do a lot of dynamic work to make this very simple, where you just spin up a VM with that project on your workstation very quickly. Make that change. So the change I'm talking about is in the source control, not on the VM. So the change that we're going to put into production is I'm going to make the change in source control to, let's say, the DSC configuration or to the ARM template. And then I'm going to try that against either Azure and a VM in Azure, or in the future against Azure Stack, or if it's just DSC, it might be against the VM itself. We're going to see if that works. We're going to get into testing, but we're going to make sure our tests work locally so that we don't even get those changes checked in to our source control branch until we've got a pretty good idea that we're on the right track. Now, here's what's interesting about source control, and I'll show you what this looks like. It does automatically create a record for you. So whenever you do a check-in, it says who made the change, what did they change, line by line, specifically what did they decide to change, and when. So now you've got a historical record, and it's always up to date. And this basically becomes your living, breathing documentation. So as opposed to saying, I have to go update a human-readable Word document that describes how to point and click and build a server, this becomes just the rugged documentation that we can not only see what the production environment looks like now, we can go back over time and see, oh, well, if 3 changes back it did work, how do we actually rebuild to just that point, and then we can troubleshoot from there. So depending on timing, I've actually got the live environment where I took these screenshots pulled up on my machine, and I can kick this off. But this is TFS. If you've seen Team Foundation Services, this is actually using TFS Express, which is a free download for 5 users or less. I picked, what you should do is someone in your organization already is using source control and a build service and has a pretty good funnel of how they take apps into production. You should align with them. So they're probably using a Git-based repository. They probably have Jenkins or Travis or any number of things. And you should align with them so that everybody's on the same page and driving towards the same goal. But if you decide that you just want to stand up something at home for your own testing, or maybe you are starting new, I picked TFS, number one, because I work for Microsoft, and it's a Microsoft product, but also because it's got everything that I needed built in. So it's an easy way for me to just kick the tires on something. So here I've just checked in the files for a basic Azure deployment, and I've got some tools that are community tools that I'm going to introduce as we go that kind of simplify the process here. So I've just checked in changes. We can see I've got comments about what I was changing as we went and when those actually occurred. I was using Visual Studio Code. So here you can see the change that I made, and I'll make a more dramatic change than this in the live demo, but here I was just saying, you know what, we're done with 2008 R2. I'm actually taking that away as an option at deploy time for this project. So the point of this is that it's showing you the change where line 61 was removed from the file, and that could be I changed the DNS name, or I changed from 1 NIC to 2 NIC, or I changed, any given change, I changed a registry key, anything I want to change about that machine. You can actually do Git commits directly from Visual Studio Code, but that also might happen from your workstation at the command line, where you're just going to use Git within PowerShell and say, number one, I'm going to test on my workstation to make sure that the quality of these changes meet the bar. I'm going to talk more about that in a second, and then do a push back into the repo. And so now I've checked in removing that line. The nice thing, like I mentioned, now you've got this durable record where you can see everything that has changed day by day, multiple times per day, what was going into production. And from a browser, I can go back and investigate exactly what changed. Now, this doesn't necessarily mean that it went into production. This means that it went into source control and it was ready to go to production. And that kind of depends on whether what your process is for moving into release. So what actually happens next? You can think about what does it look like for us to take those things and put them into production. So us actually doing the heavy lifting, us actually going in and making those changes as a human being. So what do we actually do all along? We have to do it on Saturday afternoon because that's the least amount of user impact, right? Which is perfect for us because we love coming in on Saturday afternoon. I hate going to my son's baseball games, so I'm not worried about that at all. Usually I would go in and, because I didn't mention this in the beginning, but I actually worked as an ops engineer in the environment that became O365 back when it was called BPOS. So I've got loads of experience going through change windows at scale and living out, moving towards automation. And there was a point in time where we were going through building up environments in the beginning, and we use change windows, and you would go in and use something like RDC Man because you're doing a whole bunch of servers, so why not dock all of them and get them prepped for that maintenance window? So you go and make changes and you reboot them. Basically, grab whatever your lucky charm is because, like I said, who knows if they'll come back from that reboot or not, and then check that services still work. And I'll just rapidly identify that the only thing that we consistently did is pray that things worked because we're humans. And if we remote desktop into 100 machines, there could actually be machine number 34 that I forget to reboot. And now it's just pending in production for the next week. And that's fun to try to investigate during an outage. So we've all been through similar experiences. So what do we do now? The main thing I pointed out in source control is that there were some supporting files there that are PowerShell tools that help with moving this down the pipeline. So basically, you're going to put everything in source control. So this concept of having a build service, the build service, we think about that, like if you took computer science courses in college, you think of build as I'm going to take source control, build those files into an executable, and that's the artifact of build. Whenever it's something like this, it's my build service is just going to execute PowerShell scripts. That's going to do a bunch of things for me. Now that doesn't replace automation. So one of the things that build might do for me is kick off automation. But this is going to make it extremely predictable because it all starts back with what I put in source control, and now I just have an engine that runs this for me. And if you think about every time ever that we've written a script and it worked fine on our workstation and then we put it on a server and it did not work fine at all, this helps alleviate that because you're forcing yourself to have another engine on a server somewhere validate that everything's going to work as it goes through this pipeline towards production. So triggering that build, depending on, even with TFS, you've got lots of options. So you can have it so that as soon as you save something to source control, it can go ahead and run those scripts. You can tell it to run on a schedule. You can trigger it manually. You can automate that trigger. Some systems have a polling agent, and they can look across multiple source environments. I've talked to customers who they all, within their organization, many teams share a source control, but they all have their own build platform because they didn't want contention across multiple teams doing stuff at the same time. And when we talk about test, you'll find that in a lot of cases, that build server will just run around the clock because it's validating the quality and offering a lot of what-if type scenario knowledge. It's also a really interesting opportunity to implement the just enough administration stuff that Jeffrey talked about this morning. So putting an endpoint on a server that says, as things go through this pipeline, I'm only going to allow work to be performed that I have pre-approved and built an endpoint to handle. That could be another conversation all by itself. So this is an example of a Saki script. Saki is a community tool from PowerShell. So if you think about Make, or if you ever use Ruby, they've got a solution called Rake. Saki is P-S-A-K-E, and it's just a way to standardize. Let's take the commands that we're going to run to do something with this stuff and structure it the same way in every project. So I'm going to have tests that run, and if the tests pass, then it can go on and actually make the change. And how do I set those dependencies, and how do I do that the same way so that each time that I want to take on these projects, they aren't just snowflakes all in of themselves? Saki is a really good tool for that. In this case, and the example I've got, I've actually checked in I made a contribution to the to a PS deploy project that would actually simplify this section, but you get the idea here. And there is a clean task that actually kicks things off that goes through and makes sure that if this project is running repeatedly on the same box, that any artifacts were cleaned up, and then it starts over, and if the tests work, then it goes ahead and does a deployment to Azure. Most build services are going to have the concept of a build definition. And so what I have found, especially whenever you're trying to just deliver a minimum viable product, just have a simple working example that you can prove this works. I open the default build definition, I take everything out, and I add run PowerShell. And then the goal of these projects, as I'm helping to build them, is to make them portable. So you should be able to take this project and go plug it into any build system in the world, and it should work exactly the same way everywhere. So in this case, the node that's actually doing the work is obviously running Windows, and it's just going to run PowerShell. I've got step 2 here, which is go collect my test results, but that's basically because TFS knows how to do that, and I got it for free, so I didn't have to write a script for that. All of these platforms, very similar to Azure Automation, the example given before, have the ability to store variables. What's interesting about this, as you lead towards more portability, you probably would end up moving a lot of this information to Key Vault or something like Azure Automation. But when you're getting started and you're just working through MVP, the idea of the VM local admin password or information that I've got to use to go authenticate to Azure, like my server's principal name, can be stored in the build server so that they're not getting checked into source control. And especially if you're working with public source control like GitHub, you have to be careful about what you're checking in there. There have been literally businesses go under because they put their SSH keys into source control, and people were able to get access to their AWS subscriptions. So you really want to not be shy about storing anything that might even be close to sensitive out into something that's not going to get checked into source control. Here you see for triggers, I just wanted you to get the idea that this is easy. If I do continuous integration, it's just going to say every time that I commit to source control, go ahead and run the build. Or I could say scheduled, which might mean every evening after 8 p.m. or something. I think this is just fun to watch work, but if you are in the browser and you queue a build manually, you can see the results of your PowerShell script come back, and it's just kind of fun to watch your scripts go run on a server somewhere and see that interactively. You can get used to this screen because most of your builds are going to fail whenever you're going through the process of trying. You can set the history so it cleans it out for you at the end of the day or something if you don't like seeing a sea of red when you look at your build history as you're establishing that minimum viable product. But it's not the end of the world. What this is saying is now you've got a record of every time that you tried, and this is where it gets interesting. You've got the peace of mind that it didn't go into production. So if that Saki script ran and it said, if tests pass, then go run the deployment, well, the test didn't pass, so it didn't go to deployment. And that's really starting to hit on the key of this whole talk. And we'll cover that in test a little bit more. So in this case, it did pass. It came back and said, yep, I did an Azure deployment. Here you can see every build that ran as I was going through that process. And in a lot of cases, it was just incremental, just going through and pounding on the same project until I got it to work the way I wanted. So I mentioned everything's going to go into source control, and I mentioned the concept of build kicking off your automation scripts as well. This is something that I think will happen very quickly, and I'm not seeing a lot of it yet, but I think this is coming at us, which is, if we think about how we've always done this, we would build a server, and in a lot of organizations, it goes from the design team and it gets handed off to the operations team, and that always works great. So what if in that project, before we ever went live, we said, this is how that server is going to be, right? We declared a configuration. This is everything about how it's going to get deployed. We've got build scripts and we've got test scripts that ensure quality. What if we also included in that same project, what are we going to do with this server on 30 days out? It's going to have to be patched. Service account passwords are going to have to be rotated. We've got other tasks that are just routine maintenance. So what if we took that, stored them as runbooks in something like Azure Automation, and have them launched through Hybrid Runbook Worker within our local data center, and store that in the project before we go to production? So now everything's been quality tested. It's easy to reproduce the entire environment into QA or test or whatever lab we want to use. And that can include putting the just enough administration endpoints on the machines to say when this runbook for patching connects into the VM, it can't do anything but patch. So we have an end-to-end solution from security to routine maintenance, from deployment to how are we going to maintain this machine 100 days out. How are we going to onboard into various services? So if I'm using OMS Log Analytics, can I bootstrap this machine into that environment at deploy time? Or does that have to be an afterthought that somebody comes along? Because that's another opportunity to randomize these servers. How am I going to onboard into backup services? Those are all things to start thinking about how we build those into the project. So test, to me, is the number one thing to think about. I keep saying, if I was going to learn a new skill in the year 2016, I would learn Pester. Pester is the test framework built in PowerShell. We're going to go into it a little bit today, but it shipped in Windows 10, and it will ship again in Server 2016. So this was an open source community project building tests in PowerShell, and we shipped it in Windows. So you can think about, that's pretty awesome, that the community created a project, and it is not only sort of blessed, it's actually in Windows. And it's something, if you're on a Windows 10 machine right now, you can open a open a PowerShell console window, type invoke Pester, and start playing with it. So a lot of the things here are interesting, but one of them that I think is really interesting that I've seen a lot of people struggle with is, how do I get rid of Server 2003? How do I look at eventually retiring 2008 R2? How am I going to bring Server 2016 into my environment? How do I know that my applications are actually going to work? So you can imagine if you had an environment that was built this way, it's just a matter of running these tests on another instance. And that's why I say the builds might run around the clock. So how did we do this before? We go create the VM, like I mentioned, install an OS, install the app, try the change that we want to make in production. And then we kind of make an educated guess. Like, to give you an example, you might patch a SharePoint box, and then just to make sure that it's ready for Monday morning, you open the home page. And it came up, so I'm sure it's fine. I think we've all been guilty of that, where we under-validate, right? And even if the app owner gave us a list of things, the app owner probably didn't give us an exhaustive way to make sure that this machine's ready to go back into production at the end of the maintenance window. So what do we end up doing? Let's be honest, we just didn't test. So none of that stuff ended up happening after we kind of got too busy and just decided to make changes in production. So what do we do now? The build service is going to run test automation, and it's not anything special. It's just tests that we checked in with that project into source control. So what this looks like is pester scripts, and you've kind of got it in multiple layers. So we actually get one for free. PS Script Analyzer will go through the quality of our scripts and make sure that the things that the community has identified and that the PowerShell team has identified as what we call linting, which is just going through and look at quality of the scripts. And it even looks for some things like if you have the variable $ password and it's a string instead of a secure string, it'll kick up an error. So it's basic level of what's the quality of this script. And it can run unattended, so it's great for working with build platforms. And then we can do unit tests, and if you go look at the DSC resources in the PowerShell team's GitHub repo, or if you go to PowerShellGallery.com and you drill into a DSC resource, and then you can click on a link to view the source for that, especially if they're in the PowerShell team's repo, they all have unit tests with them. They all have docs and unit tests, and most of them have integration tests as well, which the unit tests mean, okay, here's a module that maintains IIS. How do I know if I make a change it still works? So this is literally a set of tests that you can run on the build platform to evaluate the quality of the modules before they go into production that say something like, how do I know that this script is going to modify IIS? Modifies IIS correctly. Integration tests look like, let's go ahead and build a VM in test and then use PowerShell scripts that are organized as pester tests to say, did the VM that I create actually do what it's supposed to do? So if I create a domain controller, can I authenticate users? If I expected to have 54 organizational units, are they there? If I expected to have 14 sites, are they there? If I expected to have these IPs associated with those types of data. So you get the idea. It's did the outcome of this thing check out? And that's really important because you've all probably heard the analogy of cattle versus pets. So the idea of like immutable infrastructure. This kind of stuff works great for web servers because for every new version, you're just going to delete them and redeploy. Or you're going to do a blue-green cutover by just having your load balancer cut from one farm to the other. And that's easy because you can just redeploy every time. But when you start thinking about using this type of a solution for SharePoint, Exchange, Active Directory, anything that's a long-term deployment, those are all going to look like incremental changes. So you're going to be adding to that source control. This was my Exchange server. Now I'm making a change to it. I'm going from my version of Exchange 3.5 or whatever, because I'm not saying Exchange version 3.5. I'm saying my version of our infrastructure that runs Exchange, we're going from 3.4 to 3.5, right? We're self-versioning our definition of the infrastructure. And what does it look like? Okay, well, from .4 to .5, we patched, or we introduced these registry keys to help thwart a 0-day, whatever that incremental change looks like. But now we have a record that says, if that fails, this is what we're going to go back to. And I've talked to teams that will even do things like say, we're going to use Azure Site Recovery, so we've backed up all these VMs to a public cloud, and we're going to release .5 into production, but we don't patch those VMs that are sitting off to the side in Azure. And then after a week, if nothing fell over, now we'll go patch our backups. And they just have a run book that boots up those VMs into isolation, releases the same change there, and then shuts them back down. So you can really think about how the process of everything has to pass tests before we go into production. And the peace of mind that comes with that I have a good set of tests before I can go into production. And here's something that's really interesting. You're still going to have outages, right? There's just no way around it. We manage very, very complex environments. But when you go to that post-mortem and the leader in the room says, okay, guys, how are we going to make sure this doesn't happen again? You can say, well, we're going to introduce a new test. It's not that we'll never have an outage again, but this one will never bite us again because we're going to test for it from now on. And every time that we check in a change, that scenario will get tested, and if it fails, it won't go into production. And that peace of mind is pretty awesome. And that's the number one thing that has me so excited about this whole scenario. So to tell you a little bit about what Pester actually looks like, this is the DSC config. And by the way, this blog post is really awesome. I will get out of the way so that you can see the link. And like I said, the slides are in GitHub already, so I'll send out the link to it. But I stole everything on this page from this blog, and I'm just being upfront about that. So for a very interesting DSC config that deploys the domain controller, I just took a little snip of it here to give you an idea. So I'm going to create a new forest and a new domain, and I provide information about what that's going to be. Now, how do I know that that did what it was supposed to do? Here's a set of Pester tests that say, go verify that this environment is built as an Active Directory forest with this domain, and you can see, within each of the Pester tests what it's actually doing. It's basically able to run PowerShell inline and go investigate the quality of what's going on. So when that kicks off, and this is the full output of the example he gives in the blog post, he's evaluating a good deal of information about everything from password policy that are set in GPO, the number of sites, site links, and it keeps on going. So it's a really interesting test to say, okay, I'm going to make a change to an Active Directory environment. How do I know that this still works? I can spin that up as a VM. I can push this change to this new version of our AD environment to it. If all this stuff passes, I can be confident that this environment still does what it's supposed to do. To look at what that would look like back in that TFS environment, TFS actually has a tab for test. I've got a really simple set of tests for that Azure deployment. It's just evaluating the quality of the JSON environment, making sure that the stuff that should be there is there, that the JSON file is still valid. So every time that this has run, it actually is going and getting the test results. They're stored as XML and bringing them back for reporting purposes. So I can go back in at any time and say, yep, all 4 tests passed to make sure that, just a basic sanity check, I guess. You can drill in and see the individual tests that pass, and then you can drill into the individual test. And if it was a legitimate test, you would actually get a lot more information. And if you wanted to use the full functionality, almost all the different build environment type platforms have this. You can automatically generate bugs and assign that work back to somebody else or whatever the case may be. So one more thing to look at here. This is really, really cool. So this is out on GitHub as well. I stole this as well. I try to be honest about my stealings. So this is actually under the Ticketmaster repo under Posh Spec. This project is an obfuscation layer on top of Pester. So the idea was, let's build a set of, for the tests we run the most, let's build another layer so I can even do less writing, right? So if I just want to make sure that services are running, I can say, service, Win32 time, status should be running. If I want to check that a website is there, I can make that a very simple line. If I want to check to make sure hotfixes are installed, I can say, here's the KB, it should be there or not there. This file should exist and it should contain this text. He's actually generating the underlying Pester code based on interpretation of this. So it's really, all these concepts of obfuscation layers are, let's make things that were complicated really simple. And you'll see somebody come along with a project like this and make it even simpler. And I just love that idea. So I'm hugely into to community projects right now. So I just threw this in there so you can see the output is still just the Pester output. So all this is doing is making it easier to write these scripts. He's still just getting the Pester output that you would expect to see. So the final stage of this is, okay, we checked in a change, and build service picked it up, our tests ran, everything passed. We can now feel confident going into production. What does that actually look like? Previously, we'd go request a new VM. I have worked with customers where that takes up to 3 to 6 months to get a new VM, which is interesting. Hopefully it's self-service and I can get access to it right away. I might also have to request changes to the environment, so that could mean that I've got to go to the storage team and argue about why I should get a new LUN and why it should be X number of size. Go to the network team and make those same arguments there. And then I manually install the operating system from disk. I manually install the app. I then do all of our onboarding procedures. So I've got to do patch management, I've got to do monitoring, I've got to do backup, I've got to do anti-malware. And then again, go through our bulletproof method of making sure that the app works the way it's supposed to. And then I can go through a go live, which is terrifying because I'm not an expert on this app, right? If I work for a hospital, this doctor said that I had to have it, and so the app owner said, sure. And then they said, here, you're the deployment guy. Put this in and let us know whenever it's ready. Okay, great. I guess I'll get that installed and we'll see how it goes. So what do we do now? Oh, and by the way, the comedy of that one is none of these go gray. That's actually what I had to do. I had to go through every single one of those steps, and we've all lived through that experience, right? There's no shortcuts taken. It's all manual, and that's why it takes us a month to release a new piece of software. Go back. So what do we do now? Again, that build is going to run whatever we put in source control. So that means whatever we put in source control also handles our deployment. And there's community tools for this as well. But your deployment might not go all the way to production the first round. You might do something like have a build variable that you can change at runtime to say, I'm going to go to a QA environment and we're going to do user acceptance testing. If that goes well, then we'll manually kick off the build and let that go to production. So having the ability to automate this end-to-end doesn't necessarily mean that you're going to go all the way to production every single time. Let me show you real quick, and then I just wanted to speed along so that I can show you the live environment real quick. So this is the PS Deploy project. This is one that's been a personal favorite of mine for a little while, and it's just the idea of how do I take, for every different type of deployment that I have to do. Some are just content to websites. Some include spinning up a VM on VMware and deploying a DSC config to it. Some include going to AWS. Some include going to Azure. Some include going to both Hyper-V, VMware, and Azure, right, in some kind of hybrid architecture, and might include multiple steps along the way. How do I sanitize that or rationalize that so that it's the same from every project? And if I open a new project, I know where to look and what to expect about how this thing is being deployed. That's what this project is set to solve. And if you don't, the great thing about this is all PowerShell scripting. If you want to change it, you can. If you don't like this at all and you want to build your own thing, you can. It's just the idea of let's take the same approach every time. And this is a project I really like for doing that. So how do I get started on this? The first thing that I would do, if this is new to me, is start with source control. And that means everything that I'm doing, I should just start going with source control. If I write a one-off script and all of this talk about don't go to production without test is true, but you got to start somewhere. So take the process that you have and start checking in your scripts. And that allows you to collaborate with other people and stuff like that, but allows you to version them. And if somebody says, what script did you run yesterday, at least you've got a record of it. There's no way that you'll cut over to this overnight, right? Especially for existing environments. So some of you will have to look for new greenfield projects where you can say, we're going to try this alternative approach to running operations for this project and this project only for now. And we're going to see how it goes. And if it goes well, then we'll start looking at how can we, maybe baseline deployment for rebuilding environments that are in production now. Because this could definitely be part of a disaster recovery plan. Right? In some cases, it's I can redeploy every time. In other cases, it's not continuous deployment, it's continuous deployment readiness. If anybody said rebuild your Exchange environment, I could click go and it would rebuild the entire Exchange environment, and then I would restore my data from backup. And I know that it's the same environment I have in prod now. So you can kind of start thinking about how would I march this into an existing environment. You can also start looking at requiring tests. I know of people who have their build environment basically kick back anything. Well, actually, even the GitHub repo that the PowerShell team maintains for DSC resources, if you try to submit one for handoff and you don't have tests, they're going to kick it right back to you and say, if you don't have tests that prove that this should do that this is behaving the way it should, then this is no good, right? It's just a quality check. If you have managers who say, we're going to cut hours in this project, so we're not going to worry about tests because we've got to deliver earlier. Well, they'll be the same one in the outage that says, what are we going to do about this so it doesn't happen next time, right? And the answer is, we've got to have tests. That's our quality assurance to get to production. I would say keep your options open. So we have a tendency as IT pros to associate our value to our organization with the products that we support. And that's how we've become the Exchange guy, or the AD guy, or the SharePoint guy, or the Config Man guy, or the Ops Man guy. Don't let this make you the build service guy. Your value to the organization is being able to sit down with the business leader and say, we can move this really fast, right? There's going to be a change to the way we do things. And in the end of the day, we'll be able to move faster with a higher quality release, a release rate of changes into production, which means if we want to put new products on that website 15 times a day, instead of waiting until doing it once a month, we can do it, but it's going to take some changes, and here's how we're going to get there. So you can be the leader as part of that. But as opposed to traditionally being this is the product, and I'm only going to do things the way that this one product says I can, which is a little bit like this guy holding onto that server. That's not how you want to do it. And so what that means is, and this is a challenge too, if somebody on your team says, here's a new community project, I think we should look at it, and you say, but I just spent 20 hours building it this manual way. Just be objective, take a deep breath, and say, we can take a look at it, and maybe we'll look at this in a future iteration. And that's a very big change from, I only do things the way that this tool told me I could. Real quickly, it's important as you're thinking about designing this process to make change visible. So there's a community project for having PowerShell automate putting notifications in Slack. There are, for basically every chat service, I think there's one or more different projects for automating getting messages in there. Or you can do email notifications. But for every stakeholder for that application, the more that you can say a change went into production, even if it's these servers got patched, then they're aware, and even if it's not actionable, maybe they can go to reports, but people don't check reports, pretty much after the first time. So being able to keep everybody on the same page, and that's why working with chat type solutions is interesting, because right there your team is collaborating. Oh, a change just occurred in production. Huh, I didn't even know that was going out today, right? Just making that on people's radar, so if there is an outage, we know what to do. I threw this on here, so there's 2 pieces of content that I want to start working on, and I found some cohorts already for this one, which is how do I get out of an outage without randomizing my servers? And what does that look like? And that's what led me to start thinking about, why do we treat IaaS differently than PaaS, right? We would never just go to the code on a PaaS server and start making changes. We would update it, make sure it works right this time, and then re-release into a PaaS environment. So we should think about VMs as a service exactly the same way. It's just that we've got more ability to manage them. And that's something that I think we should all start taking as a challenge. The other one, and I just started working on this with Stephen Morawski, and we'll probably open it up. He made the first commit, and I owe him some changes, is if you're coming from a Linux background and you're trying this out with Windows Server, what are the things that work differently? And there's a long list of things that work differently, right? But WinRM versus SSH, scheduled tasks, services, environment variables, and just how do all these things work differently? What's package management look like that on Windows versus on Linux? A lot of these tools are intended to go broad and be able to solve problems cross-platform. Diversity of IT is just a reality that we're going to live with going forward. So I think that'll be an interesting set of content to work with as well. I created this slide this morning because I took the tubes on my way here, but I just wanted to map out what are the community projects that I would start looking at if I was going to build this. So under the PowerShell teams repo, there is a new project called Plaster, and that is awesome, and it's brand new, so you can expect a little bit of tolerance with that one, right? But it's scaffolding it's automatic generation of scaffolding. So if you're going to create a new project, you're going to need a sample Saki file, and you're going to want an example Pester scripts, and you're going to want to think about what does it mean to have a PowerShell module or a DSC module in there. So it allows you can run invoke plaster and answer some questions. What kind of project are you wanting? Which modules do you want to include, and things like that. And it assembles, it creates the starter of a project for you. So that's very exciting. And then from there, Saki is, I think it's github.com/Saki/Saki, but you can obviously Bing it, obviously. So that's a really good one to start looking at. Pester built into Windows, but look at the live Pester project. And for all these, go look at the discussions that are out there on GitHub around these and kind of get an idea for what people are looking at. I mentioned PoshSpec. There's also operational validation framework that Jeffrey mentioned this morning. So you can use these two together if you wanted. This one basically creates a wrapper and organization for Pester tests for operational validation or verifying that server does what it's supposed to do. I mentioned tools that integrate with communications platforms, so whether it's sending an email or dropping into your chat channel, those are tools to look at. And then, we can go on different routes here, but PS Deploy is very interesting. I work with it quite a bit. Mark is in the back, I think, he's the PM lead for DSC. He's been looking a lot at Lability, which is another thing that I would look at on the release phase, but it automates basically standardizing the process of, if I'm not going to public cloud, if I'm spinning up a bunch of VMs, how do I standardize what VMs I'm going to provision and what their quality should be, and then getting the code into them. So Lability is interesting. Posh Origin is similar and is VMware focused for that. So all these projects are great. And I wouldn't worry about, why do I have to go learn 20 new things? Pick the ones that sound interesting based on the requirements. Figure out what the minimum project is for you, and then pick the projects that seem interesting that you can go learn to. And if you have the opportunity, contribute back to them, because that's a really valuable thing for the community. So I'll wrap and take Q&A / maybe show a couple of live demos, but this is the point to close on, which is you cannot expect that your organization is just going to suddenly hold hands and say, great, we're going to try this new project, and we're all going to agree on it. That will not happen. All it takes, and I've seen this over and over again, is one person to say, I'm going to try this for this project, and I'm going to start kind of finding people who might be interested in this and kind of giving them an idea what I'm working on, and we're going to start building a little team on this and see how it goes. And before you know it, you're the lead, or you're at least the influencing factor that's making things like this happen within your organization. So it really can start with one person, and I'm seeing that over and over again.